This is a continuation of the standard form problems pertaining to it. Another type of problem you'll see is we're going to ask you to write the equation of a parabola with a given vertex passing through a given point. So to do this, we recollect that first of all, standard form looks like this. And we do remember that our vertex is the h and the k. Making sure we're careful with that minus sign right there. A is the number that expands it stretches it, or it shrinks it. But we don't talk about much is the x and the y. Well, x and the y are ordered pairs. There's millions of them. X comma y. These are points on the graph. And we have one of them. We have 2 comma 1. So this is going to be what we use for x and what we use for y. And this is going to be what we use for h and what we use for k. We're basically going to substitute into this red equation here. We're going to fill in everything except for a. We're going to solve for a, and then we're going to have the equation. So let's see what that looks like. I'll rewrite y equals a times x minus h squared plus k, and we're going to substitute in everything we know. Well, y, that was the ordered pair 2 comma 1, so this is going to be 1 equals, I don't know a, but I do know that the x was 2, because that was the ordered pair 2 comma 1, right there. Okay. Minus h. Well, h in this case is negative. When we subtract a negative, it becomes plus. So instead of minus negative 3, I'm going to write plus 3. And k is negative also. That's negative 5, so I'm just going to write this as minus 5. And don't forget that that was squared. I almost forgot that there. That will change the problem if you forget that. Well, first thing we can do here, 2 plus 3 is 5. I have to square that, so that's going to give me 25. So I basically got 25a minus 5. Solve for a. So we're going to add 5 to both sides. And we're going to divide by 25. We're going to leave that as the fraction 6/25. And that's crucial because now I go back to what that standard form is. I've got the a. So y equals 6/25. So you can tell that the graph will be either stretched or shrunk. I'll let you think about that before we check it. Times x minus h. Well, remember, hk was negative 3, negative 5 up on top here. Okay, so that's going to become plus 3 inside the parentheses. Squared minus 5. Again, that k was negative 5 up there. So let's show that we are right. This, by the way, is the final answer. That is the parabola with the vertex. And we can see the vertex here by looking at this is negative 3, negative 5. So that part we should be convinced of. But what I want to demonstrate to you here is that this actually goes through the point 2 comma 1. Let's shrink that. Okay, so where I had something else in there for a while. Okay, so 6/25 in parentheses. Okay, make sure you put the fraction in parentheses. Otherwise, you're only going to be multiplying the 25 times the following parentheses, not the 6/25. So we have x plus 3 squared, quantity squared, minus 5. So if I go to the graph, or the table, I'm sorry, I go to x is 2, I see y equals 1. So this graph goes through the point 2 comma 1, and it has the vertex of negative 3 comma negative 5, sorry, I forgot the negative there. We have the right answer. We can try that again if you would like another problem to practice with here. So this time we're going to find the standard form. the parabola. We're going to make up a vertex. This time we'll use some positive numbers. We'll say positive 6, negative 4. So now we go with a comma. Positive 6, negative 4. And we're going to make it pass through a pair that, an ordered pair that I know it could pass through. First of all, it can't be 6 comma anything because that would imply a vertical line, which wouldn't be a parabola. So I'm going to choose an x value of, let's say it's going to go through the ordered pair 1, comma, I don't know, negative 2, let's just say. Let's see what that leads us to. It might work out nice. It might be a little bit nasty. Let's see. First thing we realize is what standard form is. And again, feel free to pause this video and try the problem, and then come back and resume the video and pause it as you need to in order to make corrections and still pursue on your own. So we're going to do a substitution here, everything that we know from above. So what that's going to look like is my y value. I don't know a. I know the x value. And I know that h is 6. So I have 1 minus 6 squared. Plus k. K is negative 4. I'm going to put minus 4. 1 minus 6 is negative 5. I need to square negative 5. That's positive 25. I add 4 to both sides. That gives me a positive 2 over here when I add 4. And so I get 2 25ths equals A. So then my equation in standard form, which once again is a times x minus h squared plus k. So that is going to be y equals, here let's do a different color, how about that? Y equals 2 25ths times x, what was h again? It went through the ordered pair, I'm sorry, the vertex was 6 comma negative 4. So x minus 6 squared, right? 6 comma negative 4. That should be it. You can see the vertex by looking at this form. Okay, the vertex is positive 6, negative 4. That is what it was supposed to be. Okay, now we have to verify that it passes through 1 comma negative 2. We use the calculator. Easiest way to do it. I suppose we could plug in x equals 1 and see that we get negative 2 for an answer. That would also work. But we live in the age of technology, so let's do it this way. 2 25ths times the x minus 6 squared minus 4. Okay. What's the math? There's 1 comma negative 2. That's what it was supposed to go through. 1 negative 2. What I had just said, another way we can do it is, I'll show you this real quick. If I plug in 1 for 6, or for x I mean, okay, squared minus 4. If I evaluate this over here, I should get negative 2, because that's the ordered pair 1 comma negative 2. Well, let's see. This is going to be 2 25ths times, again, here is a negative 5. Square that, that's positive 25. Well, what happens when I multiply here? These guys cancel. And I get 2 minus 4 is negative 2. So I've shown that I have the ordered pair x equals 1, y equals a negative 2. I showed that a different way. So this is the same thing as us going into our calculator and showing that 1 negative 2 appears in the table. It's just another way of doing it. Algebraically, for us old folks that grew up without calculators, that's how we did things. You can do it either way. You can plug them in the check, or you can do it algebraically.